ever pondered how a layer of gas in the Earth's atmosphere could be critical for our survival? Our blue planet, Earth, is a wondrous place, enveloped in an invisible cloak that shields us from the deadly ultraviolet rays of the sun. This protective cloak is none other than the ozone layer, a mysterious and vital component of our atmosphere. The ozone layer is not located just above us, but rather, it resides in the stratosphere, a layer of the atmosphere that stretches from about 6 to 30 miles above the Earth's surface. Here, it plays a pivotal role, absorbing the majority of the sun's harmful ultraviolet radiation. If this layer wasn't there, we'd be exposed to these harmful rays, which could lead to skin cancer and cataracts, and harm our ecosystems. Yet, for something so important, it's surprising how many of us are oblivious to its existence and the crucial role it plays. It's like an invisible superhero constantly working to keep us safe from harm's way. This thin layer of ozone gas composed of 3 oxygen atoms is all that stands between us and the sun's damaging ultraviolet rays. The fascinating part is that the ozone layer isn't stagnant. It changes with the seasons and fluctuates in response to changes in temperature and sunlight. It's a dynamic, living entity that's been a part of our planet for millions of years. But here's the twist. This life-preserving layer of our atmosphere is under threat. Despite its critical role, we've been unknowingly damaging it for years through the release of certain chemicals. The result? A thinning of this protective layer, more commonly known as the ozone hole. So, the ozone layer acts as Earth's sunscreen. But what happens when it starts to thin out? Let's delve deeper into the enigma of the ozone layer, its challenges, and what we can do to ensure its preservation. After all, our survival depends on it. In the mid-1980s, scientists made a shocking discovery, a hole in the ozone layer above Antarctica. This wasn't a physical hole, but an area where the ozone concentration was significantly lower than usual. It was a discovery that sent shockwaves through the scientific community, prompting a flurry of research and investigation. Our story begins with a team of British scientists stationed in Antarctica. They were working on routine measurements of the atmosphere, but what they found was anything but routine. The data showed a drastic decline in the ozone concentration each spring, a phenomenon they dubbed the ozone hole. This news was met with skepticism. Some thought it was a mistake, an error in the equipment or data processing. But the British team was confident, and they published their findings in the prestigious scientific journal, Nature, in 1985. The world took notice, and soon more teams were dispatched to Antarctica. The data was rechecked, the equipment recalibrated, and the findings were confirmed. There was indeed a significant depletion in the ozone layer above Antarctica. But what did this mean for our planet? The ozone layer acts as Earth's sunscreen, protecting us from the sun's harmful ultraviolet radiation. Without it, we are exposed to higher levels of UV rays which can cause skin cancer and cataracts, and can harm marine life by damaging the plankton at the base of the ocean food chain. The discovery of the ozone hole was more than just an interesting scientific anomaly. It was a flashing warning sign, a signal of a serious environmental issue that had the potential to affect every living creature on Earth. As the news of the ozone hole spread, so did a sense of urgency. Scientists around the world began to ask the same question. What was causing this depletion? Was it a natural phenomenon, or was it something more sinister, a consequence of human activity? The discovery of the ozone hole was a wake-up call for humanity, but what was causing it? The villain behind this environmental crime, chlorofluorocarbons or CFCs. Yes, you heard it right. These man-made chemicals were once considered modern marvels, used in a multitude of products from aerosol cans to air conditioners. But as it turns out, they were silently orchestrating a disaster in the sky. CFCs are remarkably stable, allowing them to drift up into the stratosphere over several years. Here they're exposed to intense ultraviolet light, causing them to break apart and release chlorine atoms. Now, here's where the real problem begins. One chlorine atom has the potential to destroy over 100,000 ozone molecules. That's right, 100,000. It's a destructive chain reaction that continues until the chlorine atom is removed or deactivated. This process was happening on a large scale, thinning the ozone layer and creating what we now know as the ozone hole. This hole isn't a literal hole, but a region of depleted ozone in the stratosphere, primarily above Antarctica. It's a seasonal phenomenon, peaking during the southern hemisphere's spring, when conditions are ripe for this destructive chemistry to occur. The world was oblivious to this destruction until the mid-1980s, when British scientists first noticed a rapid decrease in ozone above their Antarctic research station. The discovery shocked the scientific community and sparked an urgent need to identify the cause. When scientists pointed the finger at CFCs, it was a wake-up call. These chemicals were in widespread use, and their potential for harm was enormous. The realization that human activity was directly damaging this vital protective shield sent shockwaves through society. But understanding the problem is the first step towards finding a solution. Once the connection between CFCs and ozone depletion was established, it paved the way for one of the most significant environmental agreements in history. The damage had been done, but could it be reversed? The answer to that question led to a global commitment to protect our planet, a story we'll delve into in the next scene. So stay tuned as we journey through the efforts to heal our wounded sky. In 1987, the world came together in an unprecedented act of global cooperation, the Montreal Protocol. A pivotal moment in our history, the Montreal Protocol was a global response to an environmental crisis. The ozone hole was growing, and we needed to act fast. The world's nations convened in Montreal, Canada, and agreed to phase out the production of numerous substances that were responsible for ozone depletion. The Montreal Protocol was not just an agreement. It was a commitment, a promise to our planet and future generations. The nations agreed to replace the harmful chemicals, primarily chlorofluorocarbons, or CFCs, with safer alternatives. CFCs were used in a wide range of products, from refrigerators and air conditioners to aerosol cans. They were convenient, but at what cost? Our ozone layer was paying the price. But the Montreal Protocol was more than just a promise. It was a catalyst for change. It set the wheels in motion, inspiring industries to innovate, to think outside the box, and to find new ways to do old things. It was a beacon, guiding us towards a more sustainable future. And the results have been nothing short of remarkable. Since the protocol's inception, over 98% of ozone-depleting substances have been phased out globally. It's a testament to what we can achieve when we act together. The Montreal Protocol is often hailed as one of the most successful environmental treaties to date. Its success lies in its adaptability. It's not set in stone. As our understanding of the science grows, the protocol evolves. It's a living, breathing agreement, changing as our world changes. But the Montreal Protocol is not just about the ozone layer. It's about climate change too. Many of the substances that deplete the ozone layer also contribute to global warming. By phasing out these substances, we're not just healing the ozone layer, we're also helping to cool our planet. The Montreal Protocol showed us that when we act together, we can make a difference. But what's the current state of the ozone hole? Fast forward to today, and we're seeing encouraging signs that the ozone layer is slowly healing. The once menacing hole above Antarctica is showing signs of shrinkage, thanks to the collective efforts of nations following the Montreal Protocol. Recent scientific studies have been promising. They suggest that the ozone hole is not just stabilizing, but also gradually mending itself. This is a direct consequence of the significant reduction in the use of ozone-depleting substances worldwide. The hole reached its peak size in the late 20th century, but in recent years, we've observed a decline in its size, particularly during the southern hemisphere's spring season. However, the healing process is a slow one. It's estimated that if we continue on this path, the Antarctic ozone hole could close completely by the middle of this century. But let's not forget, this recovery has only been possible due to the stringent measures adopted by nations across the globe under the Montreal Protocol. Yet the mission is far from accomplished. We need to remain vigilant and continue our environmental stewardship. The ozone layer's recovery is not only about the hole closing up. It's about the overall thickness of the ozone layer around the globe. And while the hole is shrinking, the rest of the ozone layer is not thickening at the same pace. Looking forward, it's crucial that we continue to monitor the ozone layer and enforce regulations on harmful substances. We also need to be mindful of climate change, as it can have unpredictable effects on the ozone layer. Rising temperatures could slow down the healing process, or even create new challenges. So, the future of the ozone layer hinges on our actions today. It's a testament to what we can achieve when we acknowledge our impact on the environment and take steps to mitigate it. Remember, the health of the ozone layer is directly linked to the health of our planet. When we understand the importance of the ozone layer and take action, we can ensure a safe and healthy planet for future generations.